Good morning, everyone, and welcome to another edition of Math and Silly Hats. Today we'll be converting a mixed number to an improper fraction. Let's get into it. We are asked to write a number that has both a whole and fractional component as an improper fraction. If we don't know what those things are, let's click the explanation. So it tells us that the mixed number is the sum of these two parts, the whole number and the fraction. Okay, so to write it as a single fraction with the denominator from our fractional part, we're going to rewrite 3 as 15/5. And then we can add these two fractions together since they now have the same denominator. Visually, this looks like breaking up our 3 wholes into 3 5/5. In other words, each whole gets cut in 5, so there's 5/5 in a whole. And then we count 15 plus 3 is 18/5. So let's solve one of these examples with both the visual method as well as the mathematical method step by step. So here we're asked to convert 1 3/4 to an improper fraction. Let's do this visually. Inside whiteboard.fi, I'm going to open my equation editor, and I had 1 space 3 /4 will give me 1 3/4. Now I want to know what that is equal to in terms of just fourths. So this is the question. Now, when we're visually representing this, our first step, we're going to represent this as whole bars and fractions. And what I mean by that is I'm going to click my rectangle tool. I'm going to make sure it has no fill. And I'm going to represent a whole bar for my 1 and then fractions for my 3/4. So here's my bar, but I don't have the full bar full. I have 3/4 of it. So instead of the whole bar, I'm going to represent this as 3/4. So I'll shade the 3/4 that we have. So here's my 3/4. Here's my whole. So my step 2 is to cut my whole into the same size fractions I have. We'll have fourths in here, so I need to cut that whole into fourths. Now, of course, I had this one whole, so I'll shade it in. Now let's cut that into fourths. Now notice I don't have any fraction here. I only started with 3/4. All right, our third step is just to count the total number of fractions we have. That is our numerator. So these are all cut into fourths, and we have 1, 2, 3, 4, 5, 6, 7 fourths. So we know that 1 3/4 is the same as 7/4 because we can visually count 7 fourths. All right, let's try one more, this time mathematically. All right, we're asked to convert 2 1/5 to be an improper fraction. Let's go back into whiteboard, and here we're going to explain step by step mathematically how we can do this. Now the first thing I'm going to notice is that 2 1/5 per our explanation is the same as 2 plus 1/5. I cannot add these two because 1, 2 is a whole number and this is a fraction, and 2, even if they were both fractions, they need to have the same denominator. So I need to do some things to 2 before I can add it to 1/5. My first step will be to make my whole number a fraction by dividing it by 1. So let's just take 2 divided by 1. Anything divided by 1 is itself, so we're allowed to do this. Our second step is going to be to multiply the new fraction we just made, 2 wholes, by the fraction, our original 1/5 denominator, 5, over itself. The reason we do this is because we need to get 2/5. Well, an easy way to get wholes to fifths would be to multiply by 5. But I can't just multiply something by 5, nor can I divide it by 5. I can multiply something by 1, and I'm going to multiply by a special form of 1. Anything divided by itself is equal to 1, so 5/5 is equal to 1. Now, why did we do this? Well, let's simplify this fraction, and it'll become clear. So 2 times 5, because we can multiply the numerators, over 1 times 5 when we multiply the denominators. As we go through and simplify this, it starts to become more clear. Now I can simplify that numerator. 2 times 5 is just 10. 1 times 5 is just 5. Our final step is, now that we have the same denominators, fifths and fifths, we can simply add across the numerators. 10 plus 1, and we keep the same denominator of 5. So 2 and 1/5 will be the same as 10 plus 1 is 11 fifths. So our final conclusion is that because we got to the same denominator, we can now add the numerators. 10 plus 1 is 11, keep the same denominator, fifths. 2 and 1/5 is equal to 11 fifths. Thank you so much for your time and attention. I hope this has been helpful, and that either method of visually or mathematically changing whole numbers to fractions and then adding them to the fractional component of your mixed number has been helpful, and you can now complete these problems on your own in ALEKS. Have a great day, everybody.